Hmm. So, hello everyone, we are all set now. So, today is a live lecture going on electrical machines. In the earlier lecture, we have discussed about classification of DC machine, and we also covered about today's 8th of March. So, for a reminder, we draw the diagram machine. It is we are firstly neglecting whether the machine is generator or motor. So it has two types. First is permanent magnet type DC machine, which have field which have permanent magnet field poles, so there is no requirement of field winding. The continuous magnetic flux is generated by the permanent magnet poles. And the second one is electromagnetic DC machine, or say excitation DC machines. We can have very different names. You can find a different name in books. So these are two basic type. The electromagnetic machines are further divided into separately excited DC machine and self-excited DC machine. Now we will discuss each part in detail. This is going to be a large video, so we have to prepare a live video. So firstly we will discuss about separately excited DC machine. So suppose it is the field winding of DC machine, having V1 voltage, and it is the armature. The generated voltage in case of generator is Eg, where the resistance of armature is Ra, and here are the brushes which allows the brush drop in the armature, and the current flowing through it is Ia. The voltage obtained at the terminals is V2. Now this is the diagram for a separately excited DC generator. Now for DC motor, which is separately excited, the V1 voltage, this is the armature of the field winding is RSH, and the current flowing is RIS or IF. The current flowing through it is IF, the resistance is RS, and the voltage is V1 across field winding. Now the armature having brushes drop VB.
हार्दिक पंड्यावर बोल की गया कितनी किरण मारी है नो बोल
भाई
उसका थोड़ा सबर
रुक जाओ।
गया अच्छा
हाँ,
हाजी
so the generated or say back EMF which will be discussed later is EG, and the sorry the yes the direction is also. Now the current flowing is IA and the source connected, and the terminal voltage says V2. The resistance RA. This is this is the concept totally of separately excited DC machine. For the next thing, we will discuss about self-excited DC machine. So as the name suggests, self-excited DC machine will tell us about both the windings are excited or get supplied from a single battery source, or say a single machine can be you operated using a single source. These can be of three types. These are of three types. First one is DC shunt machine. The second one is DC series machine. And for the last one, it is DC compound machine. For a DC shunt machine, we can say that the field winding, like the field winding, is connected in parallel with armature winding. Firstly, we have discussing about DC shunt generator. DC shunt generator. So the terminal voltage will be V. The generated voltage is EG. The brush drop VB. The armature resistance RA. The current through armature is IA. The current through field is IF. The field resistance RF, current or say load current IL. So the generated voltage EG is equal to the terminal voltage plus the losses IARA plus the brush drop or brush losses VP. So from this, the terminal voltage will be equal to generated voltage minus losses. These equations are used in numerical analysis of DC machine. Whether we have to find out the terminal voltage, generated voltage, armature current, armature resistance, and field current, field resistance, anything. As we can see, IA equals to applying KCL IF plus IL. IL is equal to IA minus IF. IF is equal to due to parallel connection. See, due to parallel connection, terminal voltage V minus field resistance Rf. So this is all about DC shunt generator. And now DC shunt motor. Sorry guys. So DC shunt motor having the same diagram or same configuration. The difference is it is connected with a battery source. Say it is a battery source. Terminal voltage V, current is IL, IA through armature, IF through field, RF field resistance, RA armature resistance, brushstroke VB, and generated voltage or say back EMF EG. So from this diagram we can define the terminal voltage is equal to EG plus IA plus IARA यानी losses plus VB. So EG can be or back EMF can be defined as terminal voltage minus losses. The change can be noticed. Say the line current is equal to armature current plus field current. However, the equation for the field current will be same. So now the next concept is about DC series motor. In this machine, the field winding is connected in series with armature winding. The terminal voltage V or say supply excitation voltage, field resistance RF, IL. This is the current flowing through both the field and armature winding. So the line current is equal to field current is equal to current. So V is equal to EG generated voltage plus A RF plus VP. As the same current is flowing through the field and the armature, we can take it common. RA plus RF plus VP, or the back EMF is equal to V minus IA RA plus RF minus VP. So I have a point to discuss about DC shunt and series motor. As we see that in DC shunt generator, the field winding is connected in parallel and shares the large number of turns with minimum thickness, because the length increases the resistance and the lower cross sectional area also increases the resistance, which allows the minimum current that is required to maintaining the flux to be cut down and generate voltage can be set up in the circuit. So maximum output can be obtained. But in case of series motor, the machine with or the winding with larger cross sectional area and smaller turns is used because it allows the minimum current. Sorry, the in the above case, so the maximum current will allow, and now the minimum or so the maximum current, so the maximum current will flow through the circuit due to increase in cross sectional area and decrease in length. The resistance is very low, about 0 to about 0.4 to 1 ohm. And in case of shunt generator motor, the resistance will be 200 to 300 ohm, or it can be 350 ohm, which is much higher. So for the next case we have DC series generator. The same diagram. The field resistance RF, the current IL, the armature resistance RA, EG generated back EMF, VB, voltage drop at brushes, and it is terminal voltage which is obtained by generating. So the equations will be so I think I don't need to explain how these equations are derived. So for an assignment, the next equation will be further divided by. So we have discussed about many cases, and now we will discuss about DC compound. And in this case we will discuss only the diagrams. The equation will be further made by you, or I'll discuss in next lecture. DC compound machine. It is of two types, the long shunt and the short shunt. Say this is series field which we have discussed in the last lecture, and this is armature, and this is the shunt field. The shunt, the series field resistance RSC, RS is the shunt field resistance, and R is the armature resistance. Generated voltage E, brush stroke VB, current IA, current IF, current IL. These are the terminals. So by the direction of current, you can determine that this machine is a generator. The equation for the generator will be EG equals to V plus IA RSE plus RA plus VP, the voltage drop. Sorry, we forgot to mention. This is the equation. However, IA equals to IF plus IL. This is same. Now for short shunt DC generator. This is RF, this is RSC, or it say this is RSH, RA, VB, and EG generated voltage, current IA, IL, IF, terminal voltage V, brushstroke VB. So we have mentioned already. So now the equation will be EG equals to V B plus V plus IARA plus ILRSE, and IL can be defined as IF or IA minus IF. So we have completed DC machine, all the equations which we require. However, the DC compound machine as motor equation will be discussed in the upcoming lecture, and it works as a home assignment. So thank you guys, that's all for today.